You're right. As I was saying, kinematics is describing motion, visual, but it makes you visualize it. It makes you aware of things. That is huge. The beginning of the scientific revolution. And people did a lot beforehand. They built pyramids and cathedrals, and they messed with stuff. But to really understand the order of the universe, we needed to break this down. I mean, literally, of the universe. Now, if we could just do the same thing for psychology, maybe we'd be in good shape. But that's much harder.
Yeah.
I think that's an infinite dimensional universe. All right. So again, we use states, state 1, state 2, state 3, state 1, state 2, state 3, 1, 2, 3. And between states, 1 to 2, 1 to 3, 2 to 3, etc. Acceleration is kind of a funny one. And for that, I, as I say in the book, notation there can be kind of crazy. And so there, you know, you can kind of pick your own. And I'll show you what I mean by that in this video, and why it can be difficult to get the concept of acceleration and to sketch it.
Right.
And that's a real big focus as you work through this to clarify acceleration, how you draw it, how you label it, and what does it mean? So let's start with the meaning of acceleration very briefly. This is going to be fast. So acceleration is not velocity. Of course, I've got this in the book. I just want to do a quick review. It's not velocity. People mistake that. If I have a large acceleration, it doesn't mean I'm going fast. Okay, and I talk about that. It just means that I'm changing my velocity abruptly. So a large acceleration is an abrupt, and I'm going to write delta V. In one dimension, we don't put little arrow signs over the V, or half arrow or half arrow, because it's easier, faster. In 2 dimensions, we do. You see that in chapter 5. For now, we keep track of direction with plus and minus. Okay, a small acceleration is a gentle change in velocity. All right, that's the meaning. Now, you can have an abrupt change. You're still going slow, but you can slam on the gas pedal. You can be going slow and you can slam on the brake or crank the wheel. So it doesn't tell you how fast you're going. You can be going fast, and you probably, if you're going fast, you want a gentle change. It's a lot safer.
Right.
Right? I mean, but again, join the club. So it's funny. Oh, you're confusing me. No, you were confused. You just didn't know it, right? I mean, you can imagine a lot of examples with that, which is okay. You're also human. So that's you know, again, now you know. Knowing what you don't know is a big thing. Okay, so that's what acceleration is. Now, getting the direction of acceleration is key. So being aware of acceleration. Now, let me just do a couple of examples. I'm gonna write the general rule. I think I'll put it over here. So you show you some cases.
Mm-hmm.
And once you do that, like I said, once you do that, you can fit the puzzle pieces into the equations, and they all mean sense, and you know what you're doing. The trouble is that people that have done this for a while, they can do this stuff, the setup so fast that they the equations so fast that you think, I got to hit the equations. No, please, no. Okay. When A is parallel to the velocity, let me do it this way, sorry. The direction of acceleration. If you are increasing speed, or an object is increasing speed, and that doesn't matter, you could be going in the plus direction or the minus direction, whichever way you choose it. Oh, here's another really important point. It's so important, I'll use red. Watch this. Negative acceleration does not necessarily mean decreasing speed. And you've got exercises to deal with that. Just drop that. I see that. I see it in high school. It comes up a lot. And some books, it absolutely, in fact, saying that, people think, oh, well, let me just make it simpler. No, you're not training the whole point. If it's increasing speed, what is true is that acceleration is in the same direction, so parallel to the velocity. If the velocity is in the plus direction, acceleration's in the plus direction. I don't know, I should draw those different colors, but whatever. If velocity is in the negative direction, acceleration's in the negative direction. And that just describes increasing speed.
Okay.
And if that's bigger, it's going to be a more abrupt increase. And if it's smaller, it's going to be more gentle. But if V is positive, A is positive. If V is negative, A is negative. Stop me for those great questions, if you will. Of course, you can change velocity by decreasing speed. Now, we commonly say speed up and slow down. I had to train myself to not use that because up and down, can be mixed with literally up and down. So I use this. It's fine, but so in this case, think of acceleration comes from a push. That's chapter 7 and 8. Acceleration doesn't cause you to change velocity. It just describes what you're doing, increasing speed or decreasing speed. If you want it, something is going past, you want to increase speed, you push it in the way it's going or pull it in the way it's going. That causes the acceleration. If it's decreasing speed, you push against it. So I like to write this. A is parallel to negative V or opposite V. So check this out. If the velocity is in the, what you call, if you call it the plus direction, if velocity is in the plus direction, then acceleration would be negative. Velocity, acceleration, velocity, acceleration. However, if you call this positive, velocity is in the negative direction, acceleration's opposite means it's going to decrease speed. If velocity is negative, acceleration's positive. And it's still decreasing speed because that's all you need. They need to be opposite. Increasing speed, decreasing speed. Which way is plus? That's up to you.
Okay.
One's plus, one's minus. Here, they're both either plus or minus. Is that clear?
Yes.
Cool.
Yes.
And stick with that. It's slippery. Just, and then the other case would be turning. Well, so to turn, and let me say same speed, and then you can turn and either increase or decrease speed. We'll get into that later, but a little bit. But once you build this foundation, it's amazing. But without it, in that case, A is perpendicular to velocity. And again, the intuition is great. Think of it, acceleration comes from a push, a net push, we'll say, an unbalanced push, but a push. You want to increase something's speed, push it which way it's going.
Mhm.
So that's plus or minus. You want to decrease speed, push it opposite the way it's going. You want to make it turn, push it to the side or pull it to the side, whichever. And that's the way it'll turn. That make sense?
Mhm.
Yes.
That's it. Hold on to that. And what happens, the other thing that makes this hard, and again, that we don't have time to in a regular class go into, is that your brain and mine, or our brains, we have preconceptions. I just caught myself in one the other day. I don't know, it was yesterday. Just like, I thought we were saying this, or I thought we meant this. And then you got to kind of bring that out and realize, oh, okay. So occasionally your preconceptions might get in the way. It's very, very common in physics. So just keep relying on this guide and you will train yourself and you'll retrain your intuition. Okay, here we go. So so this is pretty quick. Now, you've got that in the book, so it's all reinforced as you read again, it starts sinking in. So now, if I drop something, and we start having to be really careful about laying the puzzle pieces out. So I'm going to call this direction vertically up. I need to see and maybe I've got a ground down here. Right now, I don't have to call that positive. In fact, if I drop something, it never goes up. So why should I call? I would call this plus, and I would call it plus y. And I usually put units next to that, but I do some other things too. So that's plus y. That's what I would call it. And then I drop something and I know that it's going to start with v1 equal to 0. And then I know it's going to go faster because it hurts more. And it's going to go faster. And the farther it falls, the faster it goes. Now, the reality is you start picking up wind resistance. So at some point, like if you throw a bug out, it just kind of floats down, not going faster and faster. But for a lot of our cases, we're ignoring things where the air is affecting it. So I got V1, V2, V3. What direction is the acceleration?
So meaning that what you're showing that it's, acceleration. Okay. Talking about velocity. So,
What direction is the acceleration?
meaning is it, when you say direction, are you talking about to the left or to the right, or? I
Up
mean,
and down.
Yeah, left, right, up, down. Use this guide.
okay.
Which one of these cases?
Okay. So with that diagram, isn't it increasing?
Decrease.
Yep, it's increasing speed. So it's this one. So if V is down, what direction's acceleration?
Decreasing.
No, not decreasing. Is it
Oh.
is it up or down?
Oh. Mm,
Go faster and faster.
So it's going down.
Yep. So the acceleration is down.
Okay.
And I just put that as an arrow. Now, yes, that's the acceleration from 1 to 2 and the acceleration from 2 to 3. If those were different, I'd have to figure out how to use a notation. I mean, sometimes I'll use A1 and A2. If
Okay.
I'm doing a problem, I would do that.
Mhm.
Because maybe it stays this for state 1 to 2 to 3 to 4, and then it changes. You hit the break from 4 to 5 to 6, and then from 7 to 8 to 9. That's my favorite notation.
Okay. That makes sense.
But it's a little bit, that's a little fancy, but it is really helpful. Minimally, especially like a lot of the problems that you'll be seeing with constant acceleration, that means that it's not going to change. So this, if I didn't show you this and I showed you this, you'd go, oh, it's going to go faster and faster downward,
Right.
because this picture is that.
Okay.
Make sense?
Mm-hmm.
Nothing to the side unless the wind blows, and that's where we get into the end of some of these chapters. All right, cool. So now what happens? Okay. Now I call that, if we ignore the arrow, I call this free fall or free flight acceleration. So I like to call it AFF. There's a particular value to that, and you'll work that a lot.
Okay.
But just getting that clear. So you can see that this is consistent with a growing velocity, right?
Mm-hmm.
Now, what if you toss a ball up? So let's get rid of this. Again, independent of your choice of which way is positive, that is vertically up away from the ground. So now, what if I toss a ball upward? Starts out going fast. What happens to the speed of the ball as it goes straight up?
Well, the speed would get less if I'm throwing the ball up.
Yeah, me too. V2, once you let it go. Now, sometimes, and this is the stuff. So you go, well, do you want me to talk about while you're throwing it? Sometimes, not too often. Or do you want right after release?
Right. Just
It's right after, because I'm going to speed it. I'm going to increase the speed. When I let go, it's going to decrease speed. And that means it's not going to go as far. In fact, what's the speed at the top? You
Well,
throw something out, what's the speed at the highest point?
would that go to 0?
0. But it doesn't stop and stay there. It decreases speed, increases speed. It doesn't stop and float. That would be really cool.
Yeah.
So I'm going to go 3, V3, and then state 4. Now, you know, we could draw it straight on the same line, but that's too messy. So I'll draw it over here. And if I do equal, now I don't have to do equal intervals of time, strobes, but if I did, it would pick up the same speed, V4, and drawing it about the same length here, V5, and then go way down here, going really fast down there.
Right. Mm-hmm.
Okay, so now check this out. What direction is the acceleration on the way up? Which case applies? Is it increasing speed, decreasing speed, or turning?
As you're
increasing.
throwing the ball up, you're saying, is it?
Yeah.
Okay. And you said, what was the question again?
So which case applies? While the ball is going up, is it increasing speed, decreasing speed, or turning?
Increasing.
Increasing speed on the way up when you throw something up?
Wouldn't
Is
it
it
be
going faster and faster up, or is it going slower and slower?
going slow and slower, but wouldn't it start to
Malene.
turn?
Right? So as it goes up, it's going slower and slower,
Yeah.
right?
Yes.
I mean, that's what happens to a ball. It goes slower and slower. Or when you jump, you go slower and slower. It just happens kind of fast. So what direction is the acceleration on the way up? If it's decreasing speed, I go over here.
So, okay.
Up or down?
Well, it'd be
Donut.
What direction is the acceleration as this goes up?
so with the, are you asking what the velocity is because it's coming down or?
No, I'm asking, so just as it's going up, what direction is the acceleration? I'm glad you asked that. You're clarifying because I get to see the tangle of the concepts.
Right.
Yeah. So as it's going up, it is accelerating. Now, by the way, we talk about decreased speed, that's deceleration, but acceleration we use to mean all of this, and that can be confusing. So when you're decreasing speed, you are still accelerating. Kind of a funny way in science we talk about that. Why? Because all that matters is that you're changing the velocity.
Okay.
So while it's going up,
It's accelerating.
it's accelerating, meaning, and it's accelerating in this way, decreasing speed. So the acceleration is opposite the velocity. The velocity is up, so acceleration is down.
Okay. Yeah, I get it now because of how you said it, but I have to picture it in my mind and then it didn't make sense.
And so you can see why so many people are left at the gate when the semester starts.
Mhm.
Just, and this is said like in 2 minutes and you move on and you go, "Well, wait." And then for some reason it isn't clicking because you haven't had time to process it. Now, wait a minute, on the way down, is it increasing speed, decreasing speed, or turning? Now the turn here is not really a turn because it just goes up and it's a straight line. So by turning, literally going around a curved path. So that doesn't count as a turn, even that's a turnaround, but it's not turning. So that doesn't
Right.
count.
Okay.
So while it's going down, is it increasing speed or decreasing speed?
So while it's going down, it's the same as going up. As it comes down, it's going to be increasing speed as it's coming down.
Right. Decreasing speed. So acceleration opposite V, increasing speed. So acceleration same direction as V. But in this case, V is down.
Right.
So which way is acceleration?
It's going to be at the opposite of the V. I mean, I'm slow. I'm sorry. I'm trying to get it together.
Yeah, no, keep doing it. Keep doing it. This is where you're going to wire it and you're going to straighten it out.
Okay.
Fine.
So
Opposite V if you're decreasing speed, same direction of V if you're increasing speed.
okay.
On the way down, which one?
Um, so it would be increasing. So it would be the first one with the
And is that
double.
up or down?
Uh,
Hmm?
well, it's going down, but the
Yeah.
as far as acceleration, meaning the speed, it's increasing because gravity is pushing that object down.
Yeah.
So, well, anything that you throw up and bring it down is going to go really quick, fast.
So which way is A on this part? Don't use logic.
Okay.
Don't use preconceptions. Just
Okay.
use this. I mean, don't
Okay.
use kind of like, oh, what you think it should be, because that can get you in trouble.
Okay. All right. So that's going up. Okay. So, oh, okay. So A would be the opposite, even though it's going down. So it would be going up, right?
Well, let's see. Opposite means decreasing speed, right?
Uh-huh.
That's what's happening here.
Right.
Here, however, what's happening?
Okay. The ball's coming down as far as with the velocity, right? But as far as acceleration, you said you always have to have something pushing it. So with A, I guess gravity is pushing it. I mean, the arrow would go up for A on that one.
So if I do this, is acceleration in the same direction or opposite V?
It would be in the same direction.
Look at it.
Oh, opposite direction. If you're talking about those two variables.
Yeah, if I look at those two. Yeah, because right now you're seeing a lot of things. So this is opposite. If that's true, then I'd be decreasing speed.
Okay, okay, okay. So then it wouldn't be. So the arrow would go down. It would be the first one, increasing speed.
Right. And so I kind of decided to color code it. On the way down from 3 to 4 and 4 to 5 and 5 to 6, acceleration is down to increase the speed. It's with the velocity. On the way up, it's opposite because it's decreasing speed. V is A is opposite V. Increasing speed, A is with V. The thing that's kind of confusing is you sort of expect something to be different. What's different is the direction of V, but the acceleration, even at the top, it's going to be down, down, down the whole time.
Oh, okay.
We say it's because of the force of gravity, but we'll get into straightening that mess out in chapter 7 and 8.
Okay.
So can you see how this says, this is opposite this, so I'm decreasing speed.
Yes.
This is the same direction as this, so I'm increasing speed. And physically, you know that just by throwing something up.
Right.
But the entire time acceleration is down. So in fact, in this process, we would say that we have a free fall is down, and I write the word down, which could be positive or negative. You get to choose that. That's up to you. And it's down a certain amount.
Mm-hmm.
And so it's down, and that certain amount is often called G, which is not gravity. And yet people call it gravity in very sloppy language because they don't know another way of saying it. That's the direction. And this is the free fall, or I call it free flight
Okay.
acceleration. I think I've gone off the board. So, and that's for the entire time. That's going to make calculations. You're going to see, you're going to derive the constant acceleration equations for motion. And you'll be able to use it to relate state 1 to 4, 1 to 5, 1 to 6, 1 to 3, 2 to 4, 2 to 5, 3 to 4, any of those, it's
Okay.
going to pay off. But you
Yeah.
got to fight for it like you were. And what's happening is, like anybody, I don't know, watching a hockey game, it's like, what are they doing? I don't know. They're just like beating each other up. I can't believe they can do that. I seriously can't believe they let people, whatever. But, so a lot's going on and you're connecting, you're seeing this and that, and maybe this doesn't matter. But that's part of what we're doing in chapter 1.
Okay.
It's very valuable. And of course, this can apply to something going up a ramp.
Mm-hmm.
And of course, a car could go faster and faster. You could speed up as you go up.
Right.
If something's just rolling, it's going to decrease speed and increase speed. So as it goes up, acceleration is down. As it goes down, acceleration's down.
Okay.
Right?
Yeah.
And,
I, I,
and
under- I understand what you're saying. It just takes me time to process it because even
totally.
when you're taking math in school and science and you're talking about gravity and this, and that, it's like,
No,
that's
I
what
know
really makes
you
stuff
are,
go over. Yeah.
you're not alone. What happens is a lot of people don't realize they jump to the equation so fast
Right.
that they might get answers, but then they get stumped. Why do they get stumped? Because they're actually confused about this and they don't realize it.
Right.
So the more, and if you do exercise this thoughtfully like you are, and then just go, okay, which way is the acceleration? It's doing this. If I tell you what it's doing, decreasing speed, I know that acceleration is opposite the V, kind of like a push against it. If it's increasing speed, acceleration is with the V.
Mm-hmm.
If I tell you the direction of acceleration, you don't know which way it's moving. If I
Right.
go like this, here's a car, and I tell you it's moving, and I say the acceleration is this way. I don't know what it could be going. If it's going to the right, then it's decreasing speed.
Right.
If it's going to the left, it's increasing speed.
Mm-hmm.
Is that positive or negative? I don't know. You got to choose. You decide.
Okay.
Plus, this could be plus, or this could be plus. I do know that if A is opposite V, it's decreasing speed. And if it's with V, it's increasing speed.
Mm-hmm.
And so there's a lot of little things to get used to and sort out. And once you do, the picture becomes clearer.
Right.
So,
Well, that's why it's called physics. So
yeah. Well, and that's why it gets a bad rap, because it is challenging.
yes.
But you can get it, because this is one of the biggest challenges.
Yes, it is. Because even in high school, I just didn't even bother. It's like, I'm not going to be able to do it.
And this is what happens. So, you blow up things, or you push things, or you spin things, and if you don't know what's going on, you watch it like a hockey game when you don't know how to play hockey. I mean,
Right.
like, whatever, that was cool, I guess,
Yeah.
but you're not aware of things until you build this up. And building this up is huge, and that's what we're taking the time in chapter 1 to do. And then we'll take this awareness and this notation and build equations and think about how big is that number, how abrupt or gentle is that,
Yes.
how fast is that, how far is that,
Mm-hmm.
and we start playing with that, and it's really quite powerful. So
Yeah. So I just got to think about it. And then once I do that, then I'm like, okay, that's what was going on. I pretty much understand what you're talking about. It's just applying it to the different examples you have as far as the sketch is concerned, and then with the application, knowing the fundamentals, then you can like put it all together. So
Yeah, but yeah, that's great. You're exactly right. And people have seen things before, whatever, like, what's wrong with you? It's like, I don't know. I don't know. I know you're supposed to get the puck in the net. You're supposed to hit it with that stick. I get that. I don't know how they skate like that, first of all. Like, how do you even do that? And then, but I don't know. I thought that guy, why was that offsides? I have no idea what you're talking about. Honestly, it's
right,
like, it's, and all you have to do is, like, okay, well, have you ever done any dancing or dance moves? No? Okay, then try this. Move your left foot. Oh, wait, you just moved your right foot. Why'd you move your right foot? I said left foot. Because I'm confused.
right.
It really is. It's just that. And
Hmm.
so keeping this straight, man, big, it's a big step. So cool. I will post this.
Okay, when you post this recording, that's going to be in the chapter 1.